Right, we are now moving on to question number 11. It reads, by sketching the graphs of y is equals to ln x and y is equals to x over x minus 1 on the same axis, show that the equation ln x is equals to x over x minus 1 has exactly 2 real roots. So you need to plot the two graphs on the same Cartesian plane, and the two graphs must intersect twice to prove that they are exactly 2 real roots. So let us start with the ln x graph. Right, so according to the ln x graph, you need to know and understand that there is no ln of a negative number. I hope you are following. There is no ln of a negative number. So that property alone, it helps you to identify the asymptote line for that graph. The asymptote is the line which the curve is not allowed to touch. So I'm saying x, which is the number in front of this ln, right, must be greater than 0 for the ln to be valid. X must be greater than 0 for the graph to be valid. So if x is greater than 0, it means x is equals to 0 is an asymptote line. Is an asymptote line, a line which the curve is not allowed to touch. Right. So what is x is equals to 0? Another name for x is equals to 0 is the y-axis. So in simple terms, we are saying y-axis, which is x is equals to 0, is going to act as our asymptote line, and our curve is not allowed to touch this y-axis. I hope you are following. Right. So after identifying the asymptotes, you then need to identify the intercepts. So you prepare a table of values, something like this. You need to find the value of y when x is 0 and the value of x when y is 0. Right, so if we put 0 on x, you get ln 0. Ln 0 is invalid. That's why x is equals to 0 is the asymptote. But let us identify the value of x when y is 0. So I'm going to put 0 on y. You get 0 is equals to ln x. Then introduce exponential both sides. So e to the power of 0, you get 1. Then e to the power of ln x, you get x. Remember, if an exponential is raised by a ln, the answer is the number or the term in front of the ln. So we are saying when y is 0, x is 1. There is a point 1, 0 where the graph is passing through. So where is 1, 0? This is 1, 0. Right. So I'm going to draw my graph here, heading towards the positive x direction. But you need to make sure that your graph approaches the y-axis, and the graph must not touch the y-axis, since the y-axis is acting as our asymptote line. So this graph is representing y is equals to ln x. I hope you are following, class. Let us move on to the next. Equals to x over x minus 1. We have two asymptotes for this graph. The first asymptote is to acknowledge that our denominator x minus 1 is not allowed to be equivalent to 0. 0 cannot be a denominator. So if we move minus 1 to the right side, you get x must not be equivalent to 1. So the first asymptote is x is equals to 1. Our graph is not allowed to pass through x is equals to 1. So let me draw the asymptote line here. X is equals to 1. This is a vertical dotted line. passing through x is equals to 1, something like this. This is an asymptote. Right, then the second asymptote line is going to be obtained if you carry out long division on this graph. You are saying x minus 1 into x. So you are saying y is equals to 1 plus 1 over x minus 1. So y is equals to 1 is another asymptote line. I hope you are following. So after carrying out the long division, right, the number that you have here is an asymptote. Why? Because if you put 1 on y, you get 1 is equals to 1 plus 1 over x minus 1. Then moving 1 to the left, you get 0 is equals to 1 over x minus 1. If you cross multiply, you can notice that x minus 1 times 0 gets 0, of which 0 cannot be equivalent to 1. So if you put y is equals to 1, it means it is invalid because we reach a stage where 0 equated to 1, which does not exist. So in simple terms, carrying out the long division, the number that you get here is another asymptote. I hope you are listening. So the first asymptote is extracted from the denominator. The denominator must not be equivalent to 0. Then the next or the second asymptote is identified after carrying out long division. So we are simply saying y is equals to 1 is an asymptote. Where is y is equals to 1? Let me put another dotted line. This is y is equals to 1. Our graph is not allowed to pass through y is equals to 1. I hope you are following. Right. So after that, you prepare the table of values to identify the intercepts. We want to find the value of y when x is 0. So if we put 0 on x, you get y is equals to 0 over 0 minus 1, you get minus 1. Minus 1 into 0, you get 0. So the first point is 0 and 0. I hope you are following. All right, so 0 and 0 is the origin, something like this. Then another point, we want to find the value of x when y is 0. So if we put 0 on y, you get 0 is equals to x over x minus 1. Cross multiplication. 0 times x minus 1, you get 0 is equals to x. So it gives you the same point. So our graph is going to come like this, passing through the origin, approaching the two asymptote lines. But you must not touch the lines. You just approach, but you must not touch. Right? Then the other one comes in the opposite quadrant, approaching this asymptote and this asymptote. I hope you are following. So for inverse graphs, if you have a Cartesian plane like this, the first graph, if it comes in the first quadrant, the second one, it comes in the opposite quadrant. If you plot in this quadrant, it means the other curve will be in the opposite quadrant. So since we have plotted the first curve here, it means the second curve is opposite to this one, and it is located in this quadrant opposite to this quadrant. You can clearly notice that our graphs are intersecting twice at this point and at this point. So you give your conclusion. Since the two graphs intersect twice, it means that the equation ln x is equals to x over x minus 1 has exactly 2 real roots. Let us move on to part B. It reads, show by calculation that one of the roots lies between 0,3 and 0,45. 3 marks, right? So this is very simple. This is a functional notation, the functional notation that you did at O level, right? Firstly, what you need to do is you create a function by moving everything to the one side, like you have ln x, right, is equals to x over x minus 1. X over x minus 1 is moved to the left side to create the function. So you are saying ln x minus x over x minus 1 is equals to 0. It means your function is f of x is equals to ln x minus x all over 2 x minus 1. Then you ignore the 0. So this is the first thing to do. Create the function by moving everything to the one side. I hope you are following. So the choice is yours. You can move x over x minus 1 to the left, or you can move even ln x to the right. The choice is yours. I hope you are following. Right. So after creating the function, you carry out the functional notation using the given values. So you are given 0,3 and 0,45. So you need to find f of 0,3. After that, you find f of 0,45. You must have one positive and one negative. A sign change implies that the root lies between 0,3 and 0,45. So if you have both positive or if you have both negative, it means the root is not lying in between. The root only lies in between 0,3 and 0,45 if there is a sign change, where one of the function is plus and the other is negative. So we are going to start by calculating f of 0,3, which is achieved by substituting 0,3 on x. You get ln 0,3 minus 0,3 all over 2, 0,3 minus 1, something like this. So if you punch this in your calculator, you get negative 0,775. Negative 0,775 is your result. Then after that, we want to calculate f of 0,45. So you are saying ln 0,45 minus 0,45 divided by 0,45 minus 1. Punching this in your calculator, what do you get? You get plus 0,0197. Something like this, right? So the fact that we have a negative and a positive, we have created what we call a sign change. So you give your conclusion by saying a sign change, right, implies that the root lies between 0,3 and 0,45. Then you are home and dry. So you can notice that the question is carrying 3 marks. So the mark allocation is 1 mark for the negative result, 1 mark for the positive answer, and the other mark is given for the conclusion or the judgment. Then you are home and dry. I hope you are listening, class. So let us move on to part C of the question. Taking 0,45 as the first approximation to the root, use Newton-Raphson method twice to find the root correct to 4 decimal places, 4 marks. Right, so according to Newton-Raphson method, the formula is x n plus 1 is equals to xn minus f of xn divided by first derivative f of xn. So we need 2 items here. We need f of x. We also need the derivative. So f of x is there already. We have ln x. minus x over x minus 1, something like this. But what is the derivative of f of x? So the derivative of f of x is simple. You are saying derivative of ln x, you get 1 over x, right? Then derivative of x divided by x minus 1, you can make use of the quotient rule. So you are saying x minus 1 squared. Remember, the formula for quotient is v du minus u dv over v squared. So x minus 1 squared is your v squared. Then you write x minus 1 is your v. You put dot product. Du is the derivative of the numerator. Derivative of x is 1. You put 1, then you put a negative. Then u is x, which is the numerator. Then you put dot product. dv is the derivative of the denominator. Derivative of x minus 1 is 1. Then you close your bracket. What do you get? You get 1 over x minus, open bracket. If you multiply 1 with this bracket, you get x minus 1. Then you say minus x times 1, what you get x all over 2 x minus 1 squared, right? So x minus x, they give you 0. You are going to be left out with minus 1 over x minus 1 squared, something like this, giving you 1 over x, minus and minus, they give you plus 1 over x minus 1 squared. So this is the derivative. I hope you are following class, right? So we can write this in inverse form. You get x to the power of minus 1 plus x minus 1 to the power of minus 2. I hope you are following. Then f of x can also be written in even form as ln x minus x, open bracket, x minus 1 to the power of minus 1. Right, so the question is saying, taking 0.45 as the first approximation, use Newton-Raphson twice. So this instruction is very important. If they are saying twice, it means you need to find x1 and x2, where 0.45 is your x0. I hope you are following. Sometimes it says once. Sometimes they become silent on the number of times. So you have to carry out Newton-Raphson until the decimal places starts to recur. So in this case, we just need to carry out Newton-Raphson twice. Right. So remember, our numerator is f of x. Our denominator is the derivative. So we have made the calculations. We now want to substitute, right? So to find x1, which is your first approximation, you need to put 0.45 on xn, or on x. In this, this is xn, xn. You need to put 0.45. So you get 0.45, right? Minus, then you put your big bracket. You write ln 0.45. I hope you are following class. Minus, then you put 0.45 on x. You write 0.45 minus 1 to the power of minus 1. You close your bracket. Put your division line. I hope you are following. Then you write 0.45 to the power of minus 1 plus 0.45 minus 1 to the power of minus 2, right? So to find the answer, we punch this in our calculator. You can punch everything in our calculator. So you are going to start with 0.45, right? Then you put negative, you put open bracket. So it depends on the calculator you are using. Maybe you are using right view. It is very simple with right view, right? So for this one, you put open bracket. This open bracket is representing the big bracket. Then you put another open bracket where we are going to punch our numerator. So our numerator is ln 0.45. So you punch ln 0.45. Then you put minus 0.45. You write 0.45 here. You put this open bracket, 0.45 minus 1, close bracket, to the power of minus 1. Then you close bracket. So we are through with the numerator. I hope you are following. Then you put your division sign. You put open bracket to prepare for the denominator. So you are saying 0.45 to the power of minus 1. This is the first term on the denominator here. Then you put plus open bracket 0.45 here minus 1, close bracket, to the power of minus 2. Then you put close bracket, you put another one, equals, you get 0.4464 to 4 decimal places required. So you write 0.4464 is the first approximation. So second approximation is now easy to calculate. You just need to play back your calculator. So on 0.45, you erase this 5, then you put 464. You want to write 0.4464. So you are going to delete 5, then on 5 you put 464. I hope you are following. So let me play back my calculator and show you how it is going to be achieved, right? So I'm going to delete this 5, right, like this. Then you put 464. So this is 464. We move on to another one. You delete this 5, you put 464. We move on to another one. You delete this 5, you put 464. We move on to another one. We delete this 5, we put 464. Then we delete this 5 again. We put 464. We delete this 5 again. We put 464. Then we are done. So you get 0.4464 again. So you can notice that the decimal places have recurred. So since the examiner is requiring you to carry out it twice, we are home and dry. So this is the easiest way of punching Newton-Raphson. Play back your calculator, erase the 5 and put 464. Then you put equal sign. Rather than punching everything to become decimals, it is time consuming in an exam. Right.